So I was saying, on the other hand, we've also learned how to cascade two inverting amplifiers to make up a single non-inverting amplifier. Non-inverting amplifier in the sense that when you put two inverting amplifiers, they both generate two negative gains. So the first one is minus RF1 over RE1. The second gain is, if kept to -1, meaning if we choose RF2 to be equal to RE2, we can keep it to -1. So if you cascade the two, you get the total gain to be AV1 times AV2, which will just result in plus RF over RF1 over RE1, which is a positive gain. So that's another alternative. Speaking of that, we have a new concept of what we call a voltage follower, which is a special type of amplifier. Voltage follower is a special type of amplifier, very popular operational amplifier circuit, which has got the unity gain. So it's a voltage amplifier with a voltage gain of 1 volt per volt. You will realize that when you speak about the voltage gain unit, we always say volt per volt. Okay, that's the unit. Why one would say volt could cancel volt, but why do we have to say volt per volt? It's a way to emphasize that this is a voltage gain. So it's one voltage, the output voltage, divided by the input voltage. Okay. So going back to a voltage follower is a special type of operational amplifier which has got a unity gain. It's also sometimes referred to as the buffer amplifier. So sometimes referred to as the buffer amplifier, or also called the isolation amplifier. And every of these have got their own meaning or reason of being used. Voltage follower, it simply means the output voltage follows the input voltage. That means if the gain is of 1, obviously, that simply means that V out is equal to V in. It follows it because if the input voltage goes high, the output voltage also goes high. When it goes low, it also goes low. And with the exact same magnitude. That's why we say it's a voltage follower. But how do we design that? So to design a voltage follower amplifier, you just have to design you can use one of the two configurations. Since we're saying the gain is unity, it's a gain of 1. That means we are having a positive gain. Then we have to go for a non-inverting amplifier in trying to design that a voltage follower. So one would say, okay, the one way to design a voltage follower would be to have a non-inverting amplifier in such a way that you would have a gain of 1. So that means you would apply, because it's non-inverting, you would apply the input signal on the non-inverting input, and on a negative input you're supposed to have a configuration of RF as well as R in, or sometimes we also use R2, R1, depends on the question. But we know why we call it F. It's because it's a feedback resistor. It's feedback resistor because it feeds back some of the output towards the input side, and that we call input resistor because it's the resistor on the input side. Okay, so we just have that will be one way, but with this non-inverting configuration, we'll have to make sure that the gain, which is normally 1 over RF over RI, should be just equal to 1, which then means that RF over RI should be 0. Right, that will be the criteria. Now, how would you how would one achieve a RF over RI which is 0? So the only condition here is that for that to be satisfied, RF should be equal to 0, as you know. So the one way one would design this then would be VI positive input, non-inverting input. On the negative input, you have RF of 0, which means short circuit. You'll have a short circuit. That puts short circuited to the non-inverting input, and you get V out here. So that will make a voltage follower. Well, it doesn't really matter if you add an input voltage of any value here. It's just a current limiting factor, because at the end of the day, what will happen is that V out will be obtained here, and it will have to be equal to Vi, which means the gain will be of 1. So most of times to design a voltage follower, we don't even put Ri. So we basically go with Ri of infinity, meaning a very big input resistance, if one would like to say so. So often we'll draw it without the Ri, but even if you put Ri, it's still a buffer. Okay. So when it comes to the buffer or voltage follower or isolation amplifier, it is important to notice that the output is connected directly to the inverting input terminal, as we said. And since VID has to be 0, then the two will have to be equal, as we mentioned. And therefore the output follows the input. That's why we call it a voltage follower. The voltage follower uses the maximum amount of negative feedback possible. That's the idea. That way we haven't got any resistance between the output and the input on the feedback line. Okay. And because of that matter, the input resistance of a voltage follower is normally very high. Right. It has to be very high. That's why I said when we ignore Rin, we're basically saying Rin, it's the same as having Rin as an open circuit, so an infinite value, right? And as we know, the input